Flight Director System, or AFDS, provides the pilots with accurate, reliable control and displays during all phases of flight. This is accomplished using a triple-channel system to achieve a FAIL operational autoland capability certified to Category 3B conditions. Another significant feature of the system is a maintenance monitor system using the Maintenance Control and Display Panel, or MCDP, to accurately record, diagnose, and troubleshoot any problems encountered. This program will introduce you to the 757 Autopilot Flight Director System and briefly describe its operation, as well as the function and location of the major system components. 3 flight control computers, or FCCs, comprise the heart of the AFDS, with integrated autopilot and flight director functions. These computers receive inputs from various other avionics systems and airplane systems, as well as pilot input and automatic control input. Primary inputs are received from the mode control panel, inertial reference units, ILS receivers, radio altimeters, air data and flight management computers, and airplane configuration sensors. This input is combined and converted into signals which move control surfaces, as well as provide flight director commands. Primary outputs are to autopilot servos, flight instruments, annunciators, stab trim, and the maintenance monitor system. The major components of the flight director system are located in 4 areas: the flight compartment, the main equipment center, the left and right wheel wells, and the tail section. The flight control computers, or FCCs, are located in the main equipment center. On the E2 rack, the left, right, and center FCCs. The FCCs provide the main computing functions for the autopilot flight director system. All 3 computers are identical, relying on airplane wiring to identify the left, right, and center channels. Cooling is provided by forced air. The output of each flight control computer drives dedicated autopilot servos. Each servo provides a mechanical input to a surface power control actuator, or PCA, and also backdrives the associated flight deck control input. Each PCA then moves its associated control surface. The lateral control autopilot servos drive aileron PCAs. Elevator autopilot servos drive elevator PCAs, and rollout guidance autopilot servos drive the rudder PCAs. The 3 lateral control autopilot servos, or LCAs, are located in the main gear wheel wells. Access is gained by opening the wheel well doors. The left and center LCAs are located in the left wheel well. And the right LCA is in the right wheel well. Each LCA contains the following electrical components: 2 solenoid valves control hydraulic pressure to the internal autopilot servo to engage pistons and the electrohydraulic servo valve, or EHSV. The EHSV controls the servo piston in response to autopilot commands. 2 linear variable differential transformers provide servo piston position and output position feedback to the FCC. A single electrical connector interfaces with internal servo wiring. The 3 elevator autopilot servos are located in the tail section. Access is through the elevator control access door forward of the APU access door. The left autopilot servo is uppermost with the center and right servo below, mounted on the torque box. Components on these servos are the same as on the LCAs. The three autopilot rollout guidance servos are located in the vertical stabilizer, forward of the rudder. Access is through an access panel on the left side of the vertical stabilizer. The left rollout guidance servo is located nearest to the access panel, next to the center and right servos. Components on the servos are the same as on the LCAs. The remaining components of the autopilot flight director system are located in the flight compartment. The rest of this program will present the location, function, and operation of these components, as well as displays and enunciations associated with the autopilot flight director system. Power is supplied through circuit breakers located on the P11 overhead panels. The mode control panel, located on the P55 panel, is the primary crew interface to the AFDS. Autopilot and flight director engage switches, mode select switches, and controls are located on this panel. Mode select switches and controls are common for autopilot and flight director functions. AFDS modes available from the Mode Control Panel, or MCP, are LNAV, VNAV, Flight Level Change, Heading Hold, Heading Select, Vertical Speed, Altitude Hold, Localizer and Approach, which is a combined localizer and glide slope mode. Mode selection is initiated by pressing the desired mode switch. The lower portion of the switch, called a dot bar matrix, illuminates. Autopilot flight director mode and status messages are displayed on both of the electronic attitude director indicators, or EADIs. The lower left and right corners of the EADI are referred to as the Flight Mode Annunciator, or FMA, and contain the mode data. The lower left FMA contains pitch axis data, and the lower right FMA contains roll axis data. Mode messages are displayed in white or green. White indicates an armed mode, while green indicates the mode is active or operating. As an example, pressing the heading hold mode switch displays heading hold in green, indicating heading hold is the roll operative mode. Pressing the approach switch displays localizer and glide slope in white on the middle lines of the FMAs, indicating localizer and glide slope as the roll and pitch armed modes. After capture, the color changes to green, and the message is moved to the lower lines, indicating localizer has become the operative mode. Note that when the operative mode changed, a rectangular box appeared around the operative message for 10 seconds. This alerts the flight crew that the operative mode has changed. Activating the captain's flight director switch on the mode control panel provides an example of a status display. The enunciation FD indicates flight director as the AFDS status. At the same time, TO is displayed to indicate that takeoff is the active mode for roll and pitch. Activating the flight director while on the ground also displays flight director command bars in the takeoff position. Switches allow the captain and first officer to select either the left, center, or right flight control computer as the source for flight director commands and displays on the associated EADI. Engaging the left FCC to command causes the status display to change from flight director to Command. When the Heading Select control is rotated, the selected heading is displayed on the Mode Control panel display and on the EHSIs. Pressing the Heading Select control engages the Autopilot Flight Director system into the Heading Select mode and causes the FMA to display Heading Select as the active roll mode. Turning the Speed Select knob drives the display on the Mode Control panel and the speed bug on the captain's and first officer's Mach airspeed indicators. The AFDS then uses this airspeed as a reference based upon the engaged mode. The go-around mode is used for rotation and climb-out after an aborted approach. Pressing either of the go-around switches on the thrust levers initiates go-around for the AFDS and thrust management systems. The autopilot may be disengaged by pressing the disengage switch on either control wheel. An autopilot warning is activated when this switch is pressed and no autopilot channel is engaged. This permits push to test of the warning function. An autopilot disengage warning consists of illumination of a red autopilot disconnect light on the P1 panel, illumination of the two master warning lights on the P7 glare shield panel, an aural warning, a level A autopilot disconnect warning on the upper ICAS screen, and any engaged autopilot channels disconnect. The aural warning and autopilot disconnect are reset by pushing either wheel disconnect switch or by re-engaging the autopilot. Conditions which do not cause an autopilot disconnect, but which require immediate crew awareness, are enunciated by an amber caution light on the P1 panel, as well as amber master caution and ICAS messages. As an example, when the heading hold mode is active, loss of heading reference activates the following messages. On the EADIs, the heading hold display has a segmented yellow line through the display. The amber autopilot light on the P1 panel illuminates. Amber master caution lights illuminate. A yellow autopilot message appears on the upper ICAS, and an aural annunciation is sounded. Master caution lights may be canceled by pressing either lens cap. The remaining caution messages are removed by disengaging the autopilot, engaging a different autopilot mode, or if the failure is corrected. There are two Autoland status annunciators on the P1 and P3 panels, which provide the flight crew with Autoland status for approach and landing. There is an upper and lower display on each annunciator. The upper display indicates the system's actual Autoland status. The lower display indicates a degraded capability caused by single or multiple channel failures. There are two test switches on the Autoland status annunciator. Pressing test 1 rotates both displays to display the A faces. Pressing test 2 displays the B faces. A reset switch is used to clear the lower display during actual operation. An additional major component associated with the Autopilot Flight Director system is the Maintenance Control and Display Panel, or MCDP, located in the Main Equipment Center. The MCDP combines flight fault storage and ground test functions for the AFDS, as well as for the flight management and thrust management systems. The MCDP powers up at touchdown and stores faults which occurred during the last flight. Fault data retrieval and ground testing can be accomplished at the MCDP or from a remote panel in the flight compartment. Post-maintenance verification and Autoland confidence tests Provide for systems integrity prior to dispatch.